So welcome to CO232 week 3. This week we're starting a very important subject, which is file systems. And we're going to talk about file systems for a couple of weeks because file systems are a foundation of any operating system. Okay? A lot of times when the server crashes, when the server isn't working well, it's because something is going wrong on the file system. It could be the performance of the file system, it could be the sizing of it. All kinds of elements are involved here. But let me ask this question. What types of file system are you familiar with so far? Even on Windows, what file system types have you used? Or does it even make any sense when I ask about it? You know, what's a file system type? Please. Okay, so NTFS, or the Windows NT, the network file system, so FS. And then FAT32, FAT32. In Linux, FAT32 is called VFAT. All right, so FAT32. Now, those are two different file systems. How come Windows has two? Why not just stay with FAT32?
They have 4 GB transfer limit on disks, and it's less secure.
All right, so there are some limitations to certain file system types. Today we'll talk about the Linux file system types. But on FAT32, which is the older file system type in Windows, so you look at Windows XP, Windows 98, there were additional limitations. What else is the problem with FAT32? Anybody remembers? What are some of the issues with FAT32? What's that? Partitions. Okay, all right. Any other ones? All right. Now, FAT32 actually was old enough that most Linux systems actually developed compatibility. And if you notice today, many of the flash drives continue to have FAT32 as the file system. But here's the interesting thing. FAT32 had a limitation as to how large the file could be on it. What was the maximum size of the file that you could have?
4 GB.
Actually, just 2 gigabytes, yeah. So today, when you have a maybe 8 gigabyte flash drive, if you have FAT32 file system on it, you try to copy a large file, maybe a DVD or an ISO file, it's not going to let you do that. It'll say can't copy the file. The other problem was with security. You could take a disk, FAT32 disk from one computer, put it in another computer, and see all the files. Right? So that was a problem, which is why NTFS came along, and there was some indexing added. Security was added. You could do things like compression, and then the files could be of large type, and the performance of the file system was improved. So as time goes on, newer file systems are developed, improvements are made. In Linux, we have file system type of ext2, then ext3, which is an upgrade, and ext4 currently is the status quo. And the improvements are around journaling. So in ext2, when you crash a Linux server, the system would reboot, and then it would have to scan the entire file system, all the files, to see if some of them were corrupted. ext3 added this little thing called journal, so that when the kernel opened a file for writing, it would mark in the file system which files are open. So when you crash the Linux system, during the restart, all it has to check are the files from the journal that were open before. Okay, a nice improvement. And those are the kind of things that are improved over time. Performance is another thing. You know, how much quicker can we write files to the system? And you notice with the ext4, when we were doing installation, you had the option to encrypt the file system as well. Yeah, so quite a few adjustments and improvements. Let me open my virtual machine, and we'll go over some of the basics of file systems. So I'll open the VM player, and most of you should have a system already available. If you do not, then I can help you open a different system. Okay, so did you log into your email? Oh, you already activated. Perfect. So now you're in. Great. So if you go ahead and open the VM player. So let's go to Start, and then find VM player. Yep, it'll be VMware is going to be towards the bottom. Yeah, so if you missed last week and you do not have a system installed, make sure to go to Programs, then VMware, yep, and then VM Player right there. Yep, just say that you agree and then OK. OK, and then there are no systems on your virtual machines. All right. In that case, what you can do right now is just go ahead and put in the ROM that came with your textbook in the DVD, and then and we'll take that for. What's that?
This is the same book that I had, then we were supposed to take the book back.
Say it again, please.
We had this is the book that we had for the class.
Yep.
We had to take the book back because it was supposed to be a different book.
You can
That book never.
you could exchange the book, so that way it included the code.
I took it back and waited for the next book. Then, like I said last week, I was
Okay.
sick, so.
Okay. So go back to the bookstore and just pick up the book that they currently have there.
Okay.
It'll be okay. Yeah. You can use the CD. Okay. Yep. So go ahead and put it in, and we'll resume momentarily. Yes. Say it again. Oh, on a different computer. Can you do you remember how to do it? Just to reinstall. If you create a virtual machine, do you have the disk? Yeah. Go ahead and just install one more time. Okay. It's not. Are you unable to log into?
I just logged off for a second because I was.
Okay. To log off. Okay. Okay. So there is no immediate need for you to actually be looking at the desktop, but I want everybody to sort of catch up to the same place. So if you do have to install, you're right there. Okay. Good. All right. So what I'll do is I'll demonstrate some things on the screen, and that's all right. Okay, so file system. All right, we're talking the disk itself. When you talk about, or when I talk about file system, okay, we start at the disk level. So there's a hard drive that has some magnetic properties, allows you to store zeros and ones. And the hard drive is just raw disk. What do we have to do with raw disk before we can use it? Format it, yes. So when you format, you create these buckets, okay? And these buckets can be larger, smaller. Sometimes you choose the better file system for a database versus a web server. So when you format, you create buckets, and in those buckets, parts of files will go later on. Okay, if you're going to have a database server that is going to have very large files, and some databases can have files into many gigabytes, you might want to have a file system that has large buckets, because then you can save the files much quicker and also retrieve them. So file system types and the type of a file system that you install may have those options of actually adjusting the number of buckets and the size of them. So once we formatted the disk, we can then start saving files onto it. So on a Linux system, you can look at the file system by just double-clicking on the computer icon. And it's important to mention that file system, the expression, is a little bit overloaded. So many things are going to be called today file system, and so we'll work through them. In general, file system, as it is on the screen right now, it is just our disk. Okay, file system is our disk. When we talk about file system type, which we did a little bit earlier, we're talking about what kind of formatting goes on the disk. Okay, but having said that, on a specific file system, you can have, on a Linux system, you can have multiple file systems. You could have VFAT, you can have ext3, ext4. All of them can make up your system. All right, so when we double-click on the file system, we have directories. On Windows, you probably call them folders. just because they have that visual representation. In Unix, we call them directories because we come from the terminal perspective. So in the terminal, you go from one directory to another, but they're really the same thing. The nice thing about this visual or graphical user interface is that you can right-click on a folder or a file. You can go to Properties. You can set permissions through the GUI. It works really nicely. Okay, you can work with files just like you would do on other operating systems like Mac or Windows. At the same time, okay, we can work with files by using a terminal. So now we are inside of a terminal, and by the way, the terminal can be graphically enhanced in different ways. You can have a terminal that is white in the background. You can have a terminal that's black. It's up to you what the colors look like. Yes? Oh, sure, sure. So the terminal itself, you go to Applications, System Tools, and then the terminal is at the bottom. Yeah, the terminal is at the bottom under System Tools. All right? So now I am in the terminal, and I can still see files, and I'll be able to see folders, directories, and I can work with them. Now, most of the Linux Plus certification is going to be about the terminal and what commands we can use in the terminal. The desktop works great when you are at the console and you have a mouse to work with and you can start clicking around. Much of the time, though, when you work with Unix systems, you'll do that remotely, and you will do that through the terminal. Maybe you just have the phone to work with, and it has the terminal window, and you attach to a remote system. Or maybe you are logged into the first system, and then you hop to other systems, and all you have is a terminal connection. All right? It is not impossible to have a remote connection to a graphical user interface, right? But you need more bandwidth to do that. So it is less common to manage a Linux server through the graphical user interface. Okay, so here are some of the commands that we can use when we work with files. First of all, the ls command allows us to see what it is that we have in the current directory. Does anybody know the command to show us where we currently are? What is our current PWD? What does it stand for? Very good, yeah. So, what's that?
I just remembered the code. I didn't remember what it was for.
Very good. So, print working directory. Yeah. And by the way, at the end of chapter 2, there are just some introductory commands. You probably would remember those commands from CO232, but it was a nice review. So PWD tells us where we currently are. LS tells us what we currently have in the directory. What I see through the terminal, I can also preview through my graphical user interface, and these are the same files, right? They're the same files. So the next command that I could use is the cat, C-A-T command. What does this command do? C-A-T. What's that? Very good. So that's what it stands for. But in short, it just displays the contents of the file. So when we work with a text file, CAT allows us to see what's inside of the file. Let me switch to a super user. By the way, you do that by typing SU dash. So I will switch as a super user. You have to remember the password for the user. And I'm going to go to a directory called var log, just because we have some log files here. I want to show you what the cat command does when you run it against a longer file. It basically is going to display the entire screen or the entire contents of the file and scroll. I have the scroll available here, and the terminal can be manipulated to change how many lines of scroll will display. right? So if you have a large file, you can adjust this, and then you'll have a longer buffer in the scroll. But what can I do in order to just see one screen at a time? What if I want to see one screen at a time and then go to the next screen? Excellent, yeah. So I will use the pipe, and the pipe key is right above the enter key with a shift. And then I can say more. And then as I press the space bar, I go through the file one screen at a time. This is very useful when looking at log files. You can now preview the contents of the log file. What if I wanted to see this file backwards? If I wanted to see first the bottom of the file and then go up. This is very common because log files can be very, very, very long. So what happens is my newest events are at the bottom, right? And I want to be able to see them to the top. What would I issue here? Say it again? Now tail will allow me to see the last few lines from the bottom. So without any other parameters, I'll see the last 10 lines. And that's fine. What I want to do is I want to start at the bottom line and start previewing the file from the bottom up. How would I do that? Please. Well, less is an upgraded more command. That's a little bit of a Linux joke going on. More is less. So less basically allows you a few more commands, but it works just like more. All right. So I could say pipe to less, and now you can see I have a colon there to issue commands like in VI. But if I wanted to see the file from the bottom, and here's again a little bit of an open source developer Linux joke, it's the opposite of cat, right? Opposite of cat is dog. No, it's a TAC, and you go with the file name. So instead of saying cat, you say TAC, and then we pipe it to less or to more. And now I'm seeing from the bottom of the file, you see the date is the newest at the top, and I'm going down. All right. The date and the time is not right, and we're okay with that. I just restored from a sleeping virtual machine, and so we can always manually sync the time on it later on. So that is a very, very useful command, TAC, and it'll take us from the bottom up. Now what if I wanted to see the 10th line from the bottom, right? I only want to see one line, the 10th line from the bottom.
Would it be something like -10?
Yeah. So I could say tail. It's sort of -10, right? But yes, so 10 lines from the bottom. But now I actually see all 10 lines. I just want to see the 10th line. Oftentimes it's not the 10th line, it's the 1000th line that you want to see. So how can I see just the 10th line? And this is often used not maybe with log files, but maybe you have a XML file or text file that has data in it that you're importing in the database, and you have an error in record 5000. Well, now you want to see what the record 5000 is. Okay, here's how we would do that. We could say tail -10 or -10, then pipe it to head 1. Okay, head is another program that allows you to see a number of lines from the top. So what we're doing is we're saying, show me the 10 last lines. By the way, only show me the first line from that set. All right? So you can manipulate these commands back and forth with great flexibility to see a specific line. Okay, now what if I wanted to see only the lines of events that took place on January 16th at 9 p.m.? What could I do with that? I just want to see the events. Something happened at 9. I just want to see the events that took place at 9 p.m. what was that? You can. All right, so you can grab for it. So let's say that we go with cat messages, show me all, and then pipe, then grep. Grep is a filter command that allows you to filter, to basically provide a pattern, and you will only see the matches, or you can see the opposite, all the elements that are not matching. So here I can say grep for January 16th, 21. See, when I do that, I see all the events that took place at 9 p.m. Very, very flexible, and allows you to not only to see these messages, but I can, of course, now go and redirect perhaps into another file and then do additional things with that file. We are talking about a text file. On our file system, we are now storing a file, a text file, and we have a few tools now to work with a text file. The text file can be opened just as well with a GUI. I can go to Accessories, and gedit is here. I can then go ahead and open my file, and I see, instead of using cat, I can go ahead and open for editing with a GUI. Okay. Now, this GUI has a limitation. Let's say that I wanted to preview a file. I have a file here called install.log.syslog, and I would like to see what's inside of this file and edit it. I cannot, from the GUI, just go and say open and then go under root, right? It will not let me. So the graphical GUI editor has some limitations to it. I can only open files that I have access to. Whereas with a terminal, I was able to escalate my rights, become root, and through the terminal I can say something like, okay, go ahead and open this file for writing and allow me to edit the file. Because now I have the rights as super administrator to do that. Okay? So being able to manipulate files through the terminal does have some benefits. Okay, having said all that, notice that I could start the gedit program as root in the terminal and now provide the name of the file that I am trying to edit, and it will open in the graphical user interface. All right? This all is done because of the X Windows system that we're using, having permissions granted to programs. You can disallow that so that you cannot open programs, graphical programs of, that are not started by you as the user. But as I said on the screen, SU dash, automatically permissions were granted so that my X Windows system would accept the graphical interfaces that come from the root user. So there are all security systems involved there that we go through. All right, so the GUIs do work, and we can work with them. So sometimes, if you have a need to start a program as root, and it happens to be a graphical user interface, let's say that you're trying to manipulate the network card, you could say something like system config network. Okay, you make sure that you're logged in as root. You open the terminal, set SU space dash, and then being root, you can issue a command, and then you actually open the program as the root user. The graphical user interface is going to be created. Now I can manipulate the IP address and other settings for the network. All right. But going back to our text files, just a very basic type of a file, it's important that you choose a text editor that you can use inside of the terminal. Okay? here are a few of them that you can choose from. Nano, all right? Nano is an okay text editor. It looks a little bit like Notepad in that you can use the arrows, right? You can use the arrows, you can use the backspace to edit, and then to exit, you just press Control Exit, and it'll ask you if you want to save the file. So Nano is a fine text editor. If you'd like to use the kind of editor that's been in use for years and it can make you very, very efficient, you can use VI. And somewhere in Chapter 3, there's actually a table there with all kinds of shortcuts and keystrokes that only the uber geeks know, because VI tends to be a very complex editor, even though it's a short command, okay? It can be very complex, but because you never have to reach for the mouse, while you're typing very, very quickly, it makes you very, very efficient with coding, whether it's PHP, C++, or shell scripting or anything else, okay? All right. If you have a computer in front of you with Linux, go ahead and open the terminal. You will go to Applications, System Tools, and then Terminal, and try a text editor. Whether it's VI, if you're comfortable with that, that's fine, or Nano. You can also try other ones. I think there should be maybe Pico, but Nano will be just fine. If you don't know what to choose, try Nano first, and let's spend just 5 minutes doing that. Let me see about some of those installations that are going on. Okay, perfect. So go ahead and yeah, go ahead and put it under VM images. Mm-hmm. All right, so let's continue our discussion of really introduction to file systems. Text file is the first type of a file that we want to talk about, and you just edited it with a program through the terminal. That's great. There are other file types in Linux other than text files. Any ideas? What other file types could we have? Say it again.
Pretty much anything.
Anything?
Files, video files, music files.
Okay, yeah. So at the file system level, though, file types, for example, text files. Okay, you know, we don't care if they are letters or poems. So they're all text files. The other type of a file, like music and pictures, would be, what's that? Executable is another one, yes. But binary files. So a binary file simply means, okay, we cannot read them with a text editor. Okay, so a picture would be one of them. Maybe a compressed text file. Okay, they become a binary file. An upgrade from a binary file can be an executable file. It's a binary file that now we set an executable tag on, so now we can actually run it as a program. Okay, so a binary file has certain properties. Let's see if we can look at the binary file. In the bin directory, /bin, you are going to have a whole bunch of binary files. And notice that the terminal automatically is going to set some colors for us. When we deal with a text file, it's going to be just black. Okay? Most executable files are this sharp green, neon green. I know this is an executable file because there is an X in the first column when you see RWXR dashes and so forth. This is security that's set on the file. X's mean it's an executable file. All these right here are actually programs that you run, otherwise we know them as commands. But they happen to be binary files that have been saved, and now they are in a specific directory. The shell understands to look for files. When you type in some kind of a command, it's going to look for that program in /bin and some other directories. Okay, if we were looking just for a binary file, So let's say that first I'm going to create a text file. This is now my file.txt. This is a text file. I can go ahead and zip this file. Okay, now I zip the file, and now I have a .zip file. Perhaps I will go ahead and let's take let's get a picture file. I'll open the browser. Although there's a whole bunch of picture files under. All right. The virtual machines are a little bit slow, right? Not only is it slow, but it's in the way. So under user share backgrounds, say under images, okay, there are some images here. So I can copy this file to my current directory. So now I have a picture file, I have a zip file. Notice that the way the terminal determines the colors, okay, is through the extension. Okay, so it's there to help us. You can always turn off the coloring. Let's see. When you start the command with a backslash, it'll just show you everything black. Okay. It does that because when I type in ls, I actually don't run ls. Okay. There's this thing in Linux called aliases, and when I type in the word alias, I can see what shortcuts or aliases have been set for me. So when I actually type in ls, instead of running straight ls, I am running ls space dash dash color auto. Okay. You can create your own aliases. If you come from the DOS environment, then you might be familiar with dir, which actually works. Okay, dir works. But maybe you try to create your own program called show files, right? And right now it tells me that the command is not found. The command doesn't exist. Okay, which is okay. We are going to say alias show files to ls. From now on, when I say show files, it actually acts like the ls command. All right? All right, so you can create aliases that are very long. You can put a semicolon, and you can have multiple commands that get executed. Maybe you need to navigate to some remote part of the file system. Instead of having to do that every time you log in, you can set an alias. They'll do that for you. Okay, so that's where the colors are coming from. Let's go through a quick exercise of how to create an executable file, how to create a binary file. Well, to do that, we have to write a program with maybe something like C++. And we do this with an editor, text editor first. So whether this is Nano or VI, I will create a file here, my C program.c, and inside I'll say something like void main, and go ahead and allow me to print f and say hello world. All right, the most popular program ever, right? Hello world. So now I will save this file, and notice that at this point it is a text file. Okay, it's a text file. That's why we call it source code. That's an actual source file. So I will compile it. I will go ahead and type in GCC, which is the new C compiler, the GNU C compiler. When the GCC became available for Linux, it was a breakthrough for open source, because now you could actually distribute open source programs and people could compile them for free. Before you had to pay Borland and other companies for an actual C++ compiler, and that could have been very expensive. So the whole open source only made sense when there was a compiler that could compile things. So we'll go ahead and say GCC and then compile this for me. In Unix, oftentimes, feedback from commands is not warm and fuzzy. All right, you issue commands in Unix, and nothing displays afterwards. It just like swallows the the success story. Right now, I have a few warnings, but it's actually okay. The program was successful, right? So if you thought that I made a mistake, I never make mistakes. This right here is just a warning message. I now created an executable binary file called a.out. I could have provided, I think it's -o option, and then provide my own name for this file. But we'll just take this right here. So now my C program.c is a string, a text file, whereas a.out is a binary executable. So I can execute this file. I can do that by running a.out, and now I executed the file. To make this just slightly prettier, I'll put in a few new character strings, or I'm sorry, new line entries here. We have to recompile the thing, and now I'll rerun it, and there it is, hello world. Okay? Yes, question? Excellent question. What you're telling me is it's not working for you.
Yeah, I'm downloading.
Okay, yes, so when we were installing our Fedora systems, we could have gone under development and selected the GCC or compilers. If you would like to have the compiler running, you can say yum gcc install. You have to do that as root. And when you say yum gcc install, about 5 to 10 minutes later, when all the dependencies install and download, you'll have a GCC compiler. Okay, so that's yum gcc install. What's that? Oh, you can do it right now. That's fine. Yeah, you can do it right now. In fact, the virtual machines, you do to them whatever you need to do. Break them. I mean, that's what we want to see in this class. When you are at the workplace, be more careful with things. But here, you go ahead and break it. Another command that I'll show you here how to use is called strings, and this also may not be part of your install. Now, you cannot say yum strings install. If you try to say yum strings install, it's going to say that package cannot be found. It says something different for me. You have to say yum install strings. So say yum install GCC on the other one, and now it'll go through and it'll actually start, and it'll say nothing to do, no package strings available. Here's the problem: strings is the command. It's the program that comes in a different package. So the name of the package is different. How do you think you could figure out what package to install if you're looking for strings as the command? You would like to use strings command, but you don't know what package you need to install. How could you find that? No, because, well, it works for me because I have it installed, but most of the time, when you do not have the command installed, then also the man page is not there. So the man page is installed with a command. What's that? Info, that's another way of looking at documentation, but that documentation comes with the program. So if you do not have the program, you don't have the documentation. Okay, yes? Yes? So you type in sudo, and sudo is a special program that allows you to specify which user can run what commands as another user. So imagine for a moment that you would like some web developer to create new users, but you don't want to give them the root password. So instead, you configure the sudo system so that the web developer can say sudo user add, and it'll work for them. You use sudo because on most Ubuntu systems, you actually are are encouraged not to log in as root and then make mistakes. You're encouraged to use sudo and then issue the root commands afterwards. So sudo, it just escalates your commands to super user for the duration of the command. But you can configure it to be very granular on which user can execute what commands, and so it's very, very useful that way. Yes?
So all these commands that we're using, like sudo and stuff, were these individual applications that were compiled with our distribution of Linux?
That's correct.
And how does it know the file path?
Excellent question. First of all, for you to find out where the path is, you use the which command. So you say which and then maybe ls, and it'll tell you where the ls command is stored. Okay, there is an environment variable, and we'll get to the environment fairly soon. An environment variable called path, which has a set of directories which are going to be scanned the moment you type anything that looks strange. Okay, if you type something in that might be a command, the shell itself is going to run through all these directories and check for an existence of a program. And when finally you run something that does not exist, it'll say, okay, I ran through all those directories, I found nothing, so command is not found. But a lot of times it simply means that maybe you don't have the path set correctly when you see this message command not found. Yeah. Okay, so the question was, how do we find the name of the package when we have a command? And there are two ways of getting to this answer. One is you can use the internal database of dependencies, and you would use the command called RPM with what provides, and then provide the name of the command. So there is a way to query the internal database. The easier way, though, to do that is to Google. That's right. You got it. You Google it. So what we can say is we can say Linux strings command, and then like package, and all kinds of elements will results will show. Mostly you'll find the man pages which have been published. Okay, man pages. Let me go to. Let me go to. Let's see. Let me go to the Wikipedia. Okay, there's strings command on Wikipedia. And just going through this very quickly, notice it mentions the bin utilities as the package, right? So to get let me full screen this. To get the strings command working on your system, all you have to say is yum install bin utilities. Okay, and this is going to install, among other things, the strings command. All right. So we're running through a few things today, and we'll go back, come back to the entire subject of software installation and of running yum. But I hope that you are carrying away the impression that yum is very useful, that all you have to mention is just the name of the software that you want, and it'll do it for you. Yes?
Now, when you install them, they're found the activity, like what you've already installed on the computer. It's not pulling it from any network location.
I'm sorry, say that again, please.
When you use the yum install, it's actually installing it from
repositories. Yes.
Right.
If you were to like what, like Windows.
Like drivers that
Right. Only we're not only installing like internal, Windows files. We actually can go out and say install Firefox or install. What's the name of that Photoshop-like program that my wife hates? GIMP. Thank you. You can say yum install GIMP, and it'll get you that software. So basically, a lot of times with
point it would pull it from an internet location.
correct, and those are called repositories. and the Fedora system has multiple repositories, mirrors basically selected. So if one is not available, it'll switch to another one. Yeah, so if you were to disconnect the network wire, the yum command would not be able to install new software, right? That's the idea. The yum command was very powerful, and you can say something like yum remove, and then you can say bin utils. Okay? So then it'll work just fine without the internet access because you're removing files. But it maintains the database of dependencies and does all kinds of tricks.
So all of the installations come from those network locations.
Right, and you can configure additional ones. I think I mentioned that Google has a repository, Adobe. So if you want to know what's available, you just say yum list, and it is going to go through the list of repositories configured, and it'll show you all the software that, if you really wanted to, you could install. Yum list. Yum list. Now, what I typically do, I issue this command, yum list, yum list. Anybody knows what that would do? Make a file, yes. No, very good, Anna. So what happens is, you could see that it takes it a moment to actually connect to the internet, get the repositories, and then display. A lot of times, I quickly want to look, okay, is this software already installed, or is it even available? You can see the last column where it says Fedora and updates. A lot of times, it'll just say installed. Let me see if we can show an example. So apparently these are crazy programs. I don't have them. But I could say something like yum list and then grep install. And so we're going to look for the last column. Okay, what happened here? See. Let's see.
So can you use Git? Where would you use Git then?
I'm sorry, where?
Like I did yum install Git and I already installed it.
Okay, so then you would go to applications, you'd go to graphics, and there it is right here. That's GIMP, the new image manipulation program. Yep. So right here, as I'm looking at yum install, it basically shows me that these programs here are already installed, whereas these ones I can get if I want to. So they're not. But the point I was making is that you can create a text file just called yum list, and then quickly you can say, okay, what do we have in terms of Firefox through all the repositories, and it'll show you what you have available. Or, hey, I really would like to have Flash, so grep for Flash and tell me what we got. And so you can then go ahead and look through the software that's available. When it's in a file, it's just a little bit faster. And so it shows me here that Firefox is already installed, and it came from my local repository from the CD-ROM. Okay, so that brings us to the strings command. Okay, and here's what I wanted to show you with the strings command. You can issue the strings command on an executable, a binary program. And when you do that, it's going to go through the entire binary program. It'll skip all the unreadable code that the system would use, and it'll show you only the extracted strings that are humanly readable. So for example, hello world was extracted, and it's inside of the program. But if you were to display this program all by itself, the entire contents, then it's just a bunch of, well, just binary code that the system would be using. So strings is useful to maybe preview a program in a very basic way and just extract some of the labels that the program might be using and to output messages that it might produce. But it's a binary file. All right, binary file. So far we talked about a text file, otherwise called a regular file. We talked about a binary file, about executable file. Any other file types that you can think of? What else can we do in terms of a file type? Directory. See, directory is a file type all on its own. A directory is a file that has other file names in it. That's all it is. When you remove a file, it removes that entry from the directory file. It doesn't go to the disk and delete it, which is why when you commit computer crimes, all your files are still there, even though you went and deleted them manually, right? Because it only deletes from the file that is the directory, and it removes the name from that file. So a directory is a file type all on its own. There are a few tricks that you can do with that. For example, and in Chapter 4, we'll talk about linked files a little bit more. But in a directory, you can say, go ahead and create a link from my file to my other file. Okay? And when you do that, you just created an identical file. My file and my other file are identical in size, 13 bytes. They're identical. More than that, though, and this is unique to the Unix system, these files point to the same data on the disk. They are two, what's that? I think so. Let's try that. So when we'll go ahead and do that, and I'll start adding additional text, I save that. When I preview, notice both of them are 47 bytes. The one thing that is different is number 2 you see next to them. And that simply means that if it's a file, then there are 2 files pointing to this data piece on the disk. What do you think will happen if I delete my file.txt? What if I say remove my file.txt? Will the other one be there or not? All right, well, that's a good thought. Any other ideas? All right, well, let's look. So I deleted my file, and notice that my other file is still there. In fact, all the data inside of it is still there too. Why? Because both file names were pointing to the same data on the disk, and we can have even more and more of these names added. They all are editing the same data piece. But you see, directory is nothing else but a file with file names in it. So when you say remove file, it removes just the name from the directory. The data is still there. Therefore, the other name continues to point to a valid data piece. Okay? In Chapter 4, we'll talk about another type of a link called symbolic link, because these hard links, what I just showed you, have a limitation. You see, you can point to the same data piece, but you have to be in the same file system. A different meaning of the word file system here. A file system can also be basically the partition on the disk. So this root right here is a file system. Boot is a file system. So the hard links have the limitation that you can only link files within the same file system. And the reason for that is because when you format the disk, these buckets that I talked about will have a number, an inode number. And these inodes now can be a beginning of a new file, and the hardware link simply says, in this inode, okay, here's the inode, make sure to point 2 different names to this inode. Okay? Because each file system will start the inodes counting from 1, you cannot have pointers from 2 different file systems to the same inode, because they reside on a different set of inodes. So then the symbolic link comes in, which is different in the way that it points not to the data on the disk. it is a link to another file name. Let me show you the difference. If I say link symbolically from my other file to my file.txt, okay, now notice the signature my file arrow my other file. This symbolic link is created to the name of the file, not to the data piece on the disk. And the major difference now is that you can link anywhere on the system. You can link to any other file system because you're linking to a logical location, no longer doing operations at the file system level. And the consequence of that is that if I go and to simply delete my original file, the link is still there. The link was not aware of activity at the file system level. It just says you created this logical connection between two files, and by the way, the other file isn't there right now. It's called a hanging link, and if I try to look inside of it, it just says file could not be found, and then you can remove this link. But this linking capacity with a hardware or symbolic links is a great strength of Linux. Much software today runs on Java, so you may have Java runtime environment in one directory of version 1.6 and then 1.7 in another directory. Well, instead of copying this across multiple applications through your system, all you have to do is just create symbolic links. And then you have one copy of it, so less usage of the file system. And if you try to upgrade, all you have to do is you just switch the symbolic links from the 1.7 Java to 1.6, and you don't have to reinstall one thing. So those links are very powerful. They are not like the Windows shortcuts. Okay, Windows shortcuts are completely different. Windows shortcuts are basically little commands that when you double click on them, Windows Explorer knows to start a program from some other location. Okay, that's a link in Windows. In Unix, you actually create a different file. You can manipulate it just like another file. With those hardware links, we could create a different security key on one file and different security on another file, and then manipulate the same data.
You can make symbolic links in Windows too.
Say it again?
I said you can make symbolic links in Windows too.
Okay, okay. Is that a new thing in Windows, or?
I'm not sure. I use it for like game saves, so you can cloud save only with Dropbox.
It is with latest service, the latest service pack for this.
Okay, very nice, very good. All right, so just like the tabs in Firefox, spread to other things. If something works well in one system, it'll be used in another one, and that's great. All right, so we talked about regular files, text files. We talked about binary files. We talked about executable files, and then we talked about links, which are also file types. And then we talked about directories. Any other file types that you can think of? They're actually listed on page 91 and 92 in the textbook. Okay, the other file types that are left for us would be a named pipe and a socket. These are special types of files that are often used in networking. Let's say you have a MySQL database running. You can communicate with this database through networking, through IP addresses, or you can create a socket file, and then MySQL clients can get all the data from the database through the socket file. Also, all your networking programs, like the web browser, when they receive data from a remote system, that system writes to a socket file, and then you can pick up whatever data is coming in from a socket file. So those are used in networking. And a named pipe would be used in order to transfer data through a single file. So just like you have a pipe in a command, you can have a file that temporarily stores data, holds it, and as you write from one program to this file, you can at some point decide, now I'm ready to read, and you can start reading from that file. This was a nice workaround when file systems had limitations in size. So you could copy a very large file through a named pipe file and then just start reading the data out of there. So those are sockets and named files. Now let's talk about the last file system or file type, and those are device files. Okay, device files. What location in our logical file system would you expect to find devices at? What logical location? MNT, okay, because MNT may be like mount. How about devices? The DEV, very good, thank you. Yes, so you can go under /DEV for devices, and under DEV you'll find the kernel creating files for every device that you connected to the system or somehow exists internally. So if you have a keyboard, there's a device for that. If you have a hard drive, there's a device for it. And our hard drive, for example, has a device here called dev SDA. Okay, so I could say, show me dev SDA, and it shows me, hey, there is a device SDA. There's also SD1, SD2, and SD3, and this is how the kernel talks to all the devices. Okay, so when you format your disk, you can say fdisk /dev SDA, and now you're talking to the actual hard drive. Okay, another example, dev DVD. Whoops. Okay, there's CD-ROM, and on some systems it'll actually have dev DVD as well. Let me show you something interesting about those devices. Some of these devices start with letter C. See the first character, C? Some of them start with letter B. Okay? Most files do not have anything in this first position. If this is a directory, it starts with letter D. But these special devices, and here you have a link with an L, but the devices start with a C or a B. Any idea what the difference would be? Starts with a B, but no, that's not what it means here. No, not boot. For example, our hard drive itself has a B in front of it, but TTY, which happens to be a terminal window, it has a C in front of it. Well, the difference is it's either a character device or a block device. And the difference in these devices is very simple. A keyboard is a character device. You press a key and a character appears. What you don't want to see with a keyboard is you type characters and then after a while all of them show at the same time. But that's how a disk works. With a disk, you're going to grab a block of data and read it in. An entire block, because it's much faster. And with a disk, it's very important that the data comes through quickly. With a keyboard, the speed is not the point. The point is send one character at a time. And so these can be either character devices or block devices, depending on what they send through. This D right here is here because of raw being a directory, and then again else for the symbolic links. All right, so that takes us through through file types. These file types have to be recognized by the file system. So that's why we use ext2, 3, or 4. Those are Linux file systems that allow us to have these file types. You can't basically install Linux onto VFAT or FAT32, okay? Because it just is not going to have a capacity for these file types. All right. We went through the basic commands of displaying files. Some of the information on the disk has to do with wildcards. Let me be very clear about the difference between command line wildcards and something called regular expressions. Okay, because they're a little bit different. Wildcards are when I type in LSM star, the star becomes a shell replacement character. It is then used by the shell to match specific names of files. Whereas regular expressions is the whole language of working with strings, where you can say, I would like to see lowercase letters between A and B in the first position, followed by any other character, followed by a number, and find that kind of a file. And you can do that with a command called egrep, and that's going to work with regular expressions. Okay, but it's a more advanced way of basically filtering output, and it is not the same as the replacement characters like the wildcard at the command line. Okay, it's not the same. All right. That works well. Let's see. So there on page 107, it mentions regular expressions, and it'll give you just a quick introduction to regular expressions. Let me go back to the VI editor, because I want to show you that the VI editor is worth your time in terms of learning it. So when you start the VI editor, again, it is very powerful because you can do everything with it just with keystrokes. Not reaching for the mouse saves a lot of time on the system. VI has two modes. The command mode, where you can type in, for example, I'm searching for this character, or I would like to replace specific lines, or it has edit mode, where you start typing in data. When you press key characters like the I character, you enter the edit mode. You see the word insert in the lower left-hand corner. And so now in the insert mode, I can go ahead and start typing, and this is how you actually enter data through the insert mode. To exit the insert mode, you press what key? Escape. Yes, escape. You can always press escape. That's a very safe key. Here's the key that you don't want to press very often, which is Control-C. Control-C sends an interrupt to the program and politely says, would you die, please? All right. Now, in Unix, we're going to use all kinds of interesting expressions, like you can kill children, because kill is an actual command, and child processes are ones that you fork. So anyway, we'll talk about those things. But you can do Control-C to exit any program, Control-C. Control-D is another keystroke that allows you to stop data entry. So let's say that you're writing an email. This is how you write email at the terminal. You say, go ahead and send an email to somebody, and provide a subject, and then you provide the email message, and then you press Control-D, let's see, Control-D, and that tells the email program, okay, you're done typing email. And if everything goes well, I actually get that email, which is really nice because you can send emails through any of the commands that you produce. You can auto-generate an email out of the output of the command. You can schedule a command and then get an email from anything that you do. Yes. What email settings? Well, first of all, there is a email program called SendMail or Postgres that get installed behind the scenes, and it has to be running in order to take my request for an email and email it. But I do not have to actually specify an email account like a Gmail account or a Hotmail account, because the email, the Simple Mail Transfer Protocol request, gets generated right from my command line, and so I send out an email. It's up to me actually what the from field it looks like. So you can send as anybody, which is one of the problems with email, and you send it out. And most serious email systems today are going to look at this email and say, it was generated at this IP that I don't know anything about. It probably is not a real email, and it might put it in your filtered emails or actually reject it. But Gmail, Hotmail, and others will accept it just fine. Okay, it'll accept it just fine. A lot of times the email systems today are going to go back to the originating system and verify that the user actually exists on that system, or attempt to do that too. So obviously there's all kinds of problems with spam and email in general is not very secure. So it's sort of wild west. But that's how you can send an email. What I'm going to do is, and I don't remember if I configure that correctly, but I'll see on my phone if that actually gets there. What's that?
I got mine. I just
Sent and then worked. Yeah.
from my name at
Okay. Yeah. So if you want to automate this further, here's how you can quickly send an email. You can say test. So test is the subject, and you can basically provide the body of the email like this, pipe it into this, and now the email was just sent. So that's another way of doing that. Okay. That reminds me that I was talking about Control D to exit through email. Control C, another key interrupt, and to go back to VI. To exit VI, I would press Escape. Now I'm in the command mode again. I could press Shift ZZ. Shift ZZ will save and exit, right? Or I can provide an explicit command here to say :W for write and then Q for quit. Or I can say Q exclamation point, which exits without saving. Okay? So when I press :, I have the opportunity to type in commands. I can tell the editor to do very complex things. Let's say that I would like to replace all words installing with installed. I can do that by saying start at line 1. So I could actually do just a subset of the file, but I'll start at line 1 and go to the end of the file. The $ in regular expressions means it's the end of the file. So start at the first line, go to the end of the file. S means substitute, so replace the word installing, the word installing with the word installed, and do that globally in the file. And now it's all done. Okay, so you can be very quick with changes to the file, very efficient. And then you press the letter U to undo it. All right, you can press DD to delete a line. You can press D100 to delete the 100 lines all at the same time. Letter X would delete one character at a time, whereas CW will replace a word at a time. So when you program and you would like to replace a variable, you can do that very quickly with just CW. What else? YY stands for yank or copy. So YY copies and then P will paste it in. Whereas when you do DD, it actually cuts, but then makes it available for pasting as well. Finally, you can do an O, which does two things. It puts a new line in and puts you in the insert mode or in the edit mode. Shift A is going to allow me to start typing at the end of the line. So to continue the line. In programming, very nice and efficient. Finally, you can do / for searching. So if I'm looking for FC14, I can go ahead and just type in /. Notice color highlighting. This is possibly not working on your systems. What you have to do to make this happen, the highlighting, you have to install a package called Vim Enhanced. Okay, Vim Enhanced. So you just say something like yum install Vim Enhanced, which tells us that today the VI editor comes in a package called Vim. I think the basic package is called Vim-minimal. There's one called Vim-common. But you install Vim Enhanced, and it'll give you color highlighting. You can always turn it off by saying something like syntax off, And well, that applies if you have a file maybe like index.php, and now I'm typing lines in PHP. Huh? It is extremely nice because you see comments, for example, here would be something like this is a comment. Okay, it makes the code stand out. Notepad++ will do that on Windows, of course, and in Windows you can install gvim, which is VI for Windows, but it works like Notepad too, so you can use both. Once you get used to VI, though, you'll love gvim. So this is color highlighting, and I believe all you have to say is something like syntax off, and then it just turns it all off, and you can see back syntax on, and I'll turn it back on. Yes?
Does it have different coding packages? C# or
It does. Probably not C#. No, I'm just kidding. It probably does. But yes, for PHP, so here's an example. If I just type in the word index and then do the same, you see it's not working, which was very upsetting to me yesterday because I was trying to show how this is supposed to work, and it didn't, because you have to have the extension on it. So my understanding is that it will probably match the functions, you see, to the appropriate language. Yeah. All right. Yes. So VI, very nice and quick way of operating text files. Will make your coding great. The other text editor that's popular with developers is Emacs. All kinds of tricks in that editor as well. And the reason why I like VI is because most Linux systems, okay, some may be missing Nano, they may not have Emacs or gedit, but VI is guaranteed. Even on AIX, on HPUX, on older Unixes, VI will be there. So that's a nice thing. Let's talk for a moment about extensions on files. In Unix, extensions on files at the terminal don't really mean anything, other than help you to figure out what program to use with the extension. So in my previous example, right, I have these files and I see my.zip. Well, I know to use unzip on my.zip and it'll work, right? And so extensions are useful for this reason. And when you start using the graphical user interface, and this program here is called, I always mispronounce it, Nautilus. Is that right? Okay. So basically, that's the name of a program that acts like Windows Explorer. Okay. And you can start it at the command line. So here's the trick you can use. You can say, go ahead and start Nautilus as root, and now I'll be running a window of it with root's permissions, right? So you can use that as a trick. And so this is then everything done with root's permissions. But yes, when we deal with Nautilus, you can then double-click on myzip, and this then associates the program to unzip the file. Or if you have a .tar for an archive file, or .tar.gz for a tarball, it'll associate the correct program. You can see that this looks like an executable right here. So then the extensions have additional meaning. Okay, then the extensions have additional meaning. Some of the common extensions on the Unix system would be, let's see, okay, it would be a TGZ file like this one right here. TGZ file is a tarball file. It basically takes two extensions, sometimes you will see this file named tar.gz. Okay, same file, tar.gz. So I can use the same command to recreate this image by saying go ahead and untar, decompress tiny.tar tar.tgz, and I get my image back. Or I can say go ahead and tar the tiny.tgz, same file, different extensions, okay, but it's the same file. Let me give you an example of in the real world how this might look like. If we go to a website that might allow us to download files, let's go to the HTTPD server right here. Maybe we'll go under the downloads. Okay, you can see tar.gz is the type of a file that you would download, and all it is just a set of directories, files with source files, and they were tarred, which means it's an archive, and then it was compressed. The zip program in Windows does both automatically. It puts all the directories together and then compresses them. Okay. In the past, we did that in two steps. First, you would archive it into a tar, and then later, afterwards, you would compress the file. BZ2 is another common extension, and it's just a different algorithm for compression. Does anybody know the algorithm for zip? Zip is pretty much the extension, but what's the algorithm of compression behind it? Yeah, I'm actually just asking for the name of the algorithm. It's called deflate. Deflate. The browser itself, when it asks for a website, in the HTTP header, it has to tell the website what compression it supports, because JavaScript and HTML files these days are coming to your browser all compressed. Then your browser decompresses them. But the browser has to tell the server what compression to use. So it'll say deflate in the header. And it just means send me a zip file. The other one is gzip as an algorithm, and then BZ2 would be another type of an algorithm. And the reason why we have multiple ones is because different files are compressed better with a different algorithm. So a text file is better maybe with deflate versus a binary file would be better with gzip. And then, of course, the newer the algorithm, the little better compression you get, right? So that's sort of what those folks, smart folks, work on. All right, the other extensions, I think there's a whole table of them in the textbook. Let's see. Around page 93, .c files for C programs, .cc or CPP files for C++. The one file that you may not be familiar with from other systems. Let's see if we can come up with some of them. Okay, right here, .so files. .so files are shared objects, and basically they are plugins that can be used with another program. So in Apache, for example, you can have multiple modules attached to the main program, and as it boots, it then attaches these executable modules. Those are the shared objects. In Windows world, probably a close analogy would be a DLL file, right? So you have all kinds of DLLs, and when you start an executable, it actually attaches to those libraries and starts using that code. All right, good deal. Any questions so far? Okay, so today we talked about the file system as being the disk where we store files, And we went into a few things about files. We talked about file types. And in the future, we'll talk more about links. We'll talk about some tricks that you can use on files. And we'll take it from there. So we have a few minutes left today. What I'd like to do is, again, make sure the lab connection works for you. If you would like to rerun some of the commands that I showed here in class, you can do that. If you'd like to know how to install strings, I can help you to do that. And if you want to get started on lab connection here in class, feel free to do that. I think we have about 15 minutes or so. If not, I'll see you next week. Thank you for attending. Thank you for being this late. Thank you for not falling asleep. And we'll see you next week. Make sure to look into the lab through Lab Connection. Yes. All right. Very good. Yep. Let me just stop the. Whoops.